I am delighted to be here. Thanks for the invitation. So let me introduce to you our center called CARD, Center for Advanced Research in Drying. CARD was established as a US NSF Industry University Cooperative Research Center in 2016. And we have a co-site at University of Illinois in Urbana-Champaign. Basically, the headquarters per se is at Worcester Polytechnic Institute, WPI. This is our executive directors from both campuses, but the bottom line is we have 10 faculty members from WPI and 10 faculty members of different disciplines from Illinois working cohesively together. Drying, let me just spend a little time on this. As we all know, it's a very energy intensive process. In the US, drying accounts for approximately 10%, 1.2 quarts of all process energy used in American manufacturing. DOE's report, which I 100% agree with that, states that 0.5 quart can be saved actually by making the drying process more energy efficient. And industry sectors, at least in the US, that are very relevant to drying are basically pulp and paper, agriculture, food, textile, biopharma, and chemicals, and there are some others as well. So the objective of CARD is to reduce the cost through the energy efficiency, of course, the impact of that on the environment, the sustainability. But the bottom line is the product quality has to be equal or better. And of course, with increased throughput. So by understanding the process, not only the product quality can be improved while the energy consumption is reduced, also the throughput can increase. I want to emphasize this, that the students that are working on these projects at both campuses are really the next generation workforce in the field of drying. And I'm delighted to say that our students get hired by our member companies. So our members are listed here. I won't go through this. We have 11 members from pulp and paper and primarily from food industry, as you can see. And also we have Massachusetts Clean Energy Center and US Army as our members. I am showing you the project for the one reason. There's a reason that I'm going through these 2 pages to tell you about the projects that are ongoing right now. Sensors are critical to understand the process and improve and develop new technologies. So we have 2 projects on sensors, or maybe 3, you may say, coupled with modeling, the third one. Ultrasound, I know that you will talk about that as well, is another technique that is non-thermal to remove moisture from porous material. We have 2 projects ongoing on that. These projects, by the way, are listed in no specific order. We have developed a unique nozzle, which are bringing that to spray drying process, which is a significant portion of all the processes in food industry, and trying to make that more energy efficient. The second bullet comes from my own NASA project on ISS, International Space Station, for improving the phase change, liquid to vapor boiling process. We are bringing that to separate. Henry mentioned something about separation. Yes, you can separate the vapor phase from the liquid phase during the drying process. If time permits, I'll show you a couple of slides on that. Fundamental understanding is needed in the world of drying. Bound water is very critical to understand. We still don't have really good understanding on that. We have made really good progress in this area to understand what's the physical and fundamentals that govern removing the moisture that is trapped inside the cellulose. That cellulose could be a pulp cellulose, or it could be food or others. Now, machine learning, AI, is a must for the next generation development of the drying machines. And I have a video, if time permits, I'll show you that. And the last one is a smaller project on understanding on the surface topography. I am also delighted to say that actually one of the projects became a TRL level of 7 and 8, as we speak, is being incorporated into drying processes of 2 major food industries companies. I'm also happy to say that DOE has started to support our project in the area of drying, innovative food dehydration technologies for improving product quality, energy efficiency, and sustainability. Sorry, this is USDA project, but the DOE project, much larger project, is novel energy efficient drying technologies for food and pulp and paper and other energy intensive manufacturing industries. Basically, in this project, we are developing the next generation dryers, these smart dryers. They adjust themselves to the product that they are trying to dry under different conditions and so on. And that comes, as I will show you, with the aid of artificial intelligence. The partners in this project are listed here, as you can see. But the bottom line is this particular DOE project, where as we used Cont'd as a platform, the basic work is done in Cont'd. Now we are trying to raise the level, the TRL level. And the 3 technologies we are looking at simultaneously to look at combination of these 3 technologies. One is DEP, dielectrophoresis technology, ultrasound technology, and unique nozzles that we have already developed. We are looking at combination of these and apply AI for optimal process control, which requires integrated advanced sensors. You cannot really do any of these if you don't have the right sensors. So we are developing sensors that provides the moisture content and product quality as it goes through drying process, in situ measurements. So I hope I have this is a short video. Let me show you this.
The Center for Advanced Research in Drying intends to...
So that basically, the DOE project is enabling us to develop these 2 test beds to have combination system level that work together for optimal in terms of drying efficiency and product quality through AI. And this will be more unique to paper side, which you have a dryer drum in there, heated dryer. So in a few minutes, maybe a couple of minutes that I have, I want to tell you out of the box technology that we are bringing to drying process. It's based on EHD, DEP assisted drying technology. We have a provisional patent on this. That's why I can show you. As we apply diverging electric field and we extract the vapor as being developed within the product away from the surface, the drying process efficiency and drying rate increases significantly, as I'm illustrating here. The one on the left illustrates the surface temperature. So as you can see, in the presence of a diverging electrical field, the product is being dried at lower temperature. And as you can see on the right-hand side, it's very efficient in terms of removal and separation of the vapor phase from the liquid phase. We are not relying on the evaporation. We are, in combination with the evaporation from the surface. This mechanism enhances the drying significantly. Just very briefly, without going into details, we are talking about enhancements on the order of 33% or so in the lab scale module that we have. Energy efficiency, again, without going into details of it, the current use in this technique, in this mechanism of DP is extremely low. And the energy that goes to energize the electrode versus the amount of energy we are saving from the evaporation, that is a factor of almost 25 or so. In other words, minimal energy is used to separate the vapor phase from the liquid phase. So just a couple of last slides. CART really is eager to collaborate with others, whether federal agencies or research institutes nationally and internationally, to make the drying process energy efficient with a reduced carbon footprint, improve product quality, and increase throughput. I must emphasize, fundamental out-of-box thinking is required in order to come up with new technologies in this field. We were very lucky to bring the CART to host the next IDS, International Drying Symposium, in the United States. The last one was in 1986 at MIT campus. Now, the next one was supposed to be actually in 2020, but we postponed it twice, unfortunately. Again, this year we postponed it. So if you're interested, please mark this and participate in this drying symposium. Our semi-annual meeting, next one, is in Illinois campus, and you're more than welcome to participate and attend that meeting. That's my presentation.